Hello guys, this is Thomas Khan and today we're going to see about the heat exchanger. I think this is an interesting topic. If you want to know what heat exchanger is, what kinds of heat exchanger do we have, and also how we could select heat exchanger like for different applications that we need. So I need you to stay with me and we're going to make it more interesting through this session. So let's go into the lecture. So here we have a heat exchanger, our today's lesson. Let's start from the definition of heat exchanger. A heat exchanger is a piece of equipment built for efficient heat transfer from one medium into another. Heat transfer, I think we will try to cover another course regarding heat transfer, but the main purpose of heat exchanger is if we need it for efficient heat transfer from one medium into another, we're going to use heat exchanger. Specifically, if we want to get the what we call the transition more efficient. We do have different kinds of heat transfer mechanisms: conduction, convection, and radiation. We will see those things in another video. For today, let's stick to this heat exchanger and we will try to make the best of it. So they are widely used in space heating, refrigeration, air conditioning, power plant, chemical plants, petrochemical plants, petroleum refineries, natural gas processing, and sewage treatment. So it's kind of have a huge application. If we are really interested in this thing, we can use it in different areas, starting from space heating up to natural gas processing. This is the main thing. Heat exchanger is a device which is used for transferring the heat from one fluid into another through a separating wall. So let's start from this. We have according flow arrangement. The first one is we have a parallel flow heat exchanger. Let's take, this is the heat exchanger. The red one, this one represents for hot fluid. This one is hot. This blue one represents for cold. So as you can see here, in parallel flow heat exchanger, the two fluids enter the exchanger at the same end. They enter at the same end. This one, the hot fluid, and the cold fluid, they enter at the same end and travel in parallel to one another to the other side. That's why we call them parallel. Then they flow to the other side. This one is the red, this one is the blue, in a parallel form. So we call them parallel flow heat exchanger. This one is their output on the other side. And now also based on flow arrangement, let's see the counter flow heat exchanger. Counter flow heat exchanger, the fluid enters the exchanger from opposite side. As you can see here, this one is the hot fluid, this one is the cold, right? So they enter the exchanger from opposite end. This one enters right here, and in the other end this one enters right here. So we call this counter flow heat exchanger. The counter current design is the most efficient. This one is the most efficient. It has its own reasons. We will see them later, how we can select or we prefer the most efficient heat exchanger system. And the other one is a cross flow heat exchanger. The first one was parallel and then counter flow, and the third one is cross flow heat exchanger. The fluids travel roughly perpendicular to one another through the exchanger. As you can see here, we have this one. This one is the cold fluid, and it goes like this, right? Comes like this, and at the end it will reach here at the output. But this one comes from here into here. So they are flowing. This one is flowing here. This one is flowing here. So kind of what? Perpendicular. So this thing we call it cross flow heat exchanger.